Hello YouTube. Today we're going to be working on some lingo in math, or math as a language. So here are just some symbols that you will come across probably in calculus or even statistics. Just some of the ways to write certain things so that it's simpler to understand. Instead of writing out words, you can use symbols to show math in a more simpler way. It's like a language, it's like anything. Okay, so these are some logical quantifiers. So we have A implies B. This right here means implies. So that's A implies B was B how you would say it in English or in words. And this is an example. So say x is a multiple of 4. This would imply that what? X is even. Let's try another one. Well, here's another symbol. So what if you flip the arrow? Flipping the arrow would be saying A is implied by B, or if B, then A, but it doesn't really matter how you'd say it. You could even say or B if only A. So you could say that in 3 different ways. You could say A is implied by B, if B then A, or B if only A. But let's just do A is implied by B. An example of this would be if sine of x equals 0, then what does that imply? So this is implied by x being 0 or x being negative pi, because sine of x equals 0 at 0 and negative pi. And one thing to note is that A implies B also means the same as B is implied by A. So you can notice how the arrow is pointing in the same direction. They're both pointing towards B. Not same direction, but both pointing towards B. That's how you can tell that I guess they're the same. Let's do another example. So this symbol, if there's a double arrow, means A if and only if B. And another way of saying if and only if you can abbreviate that is if with an extra F, so IFF. And that means if and only if. An example of this would be if you had x squared equals 9, that means if and only if x is 3 or negative 3, because when you take the square root of both sides, you get plus or minus 3. Another example would be if today is Friday, if and only if yesterday was Thursday. So I guess you can think about that one. Okay, so what if we had A, therefore B? So those 3 dots mean therefore. So that's how you would say it in English or in words, A, therefore B. Another way you could say it is B is true because A is true. That's pretty much what therefore means, because. Okay, let's have an example. So the first one, California is in the Pacific time zone, so therefore I'm in the Pacific time zone. So if I were in California, then I would say I'm in the Pacific time zone. Okay, next one. Every prime number is either odd or 2, and 19 is a prime number. So then what? That would be, therefore 19 is odd. Okay, let's do some examples of all these that we did before, and I'm going to have it be an exercise so you guys can actually test if you've actually learned the material. So I encourage you to actually try before I reveal the answers. So here's the first one. X equals 5. Then what does that show about x is odd? So what arrow would you use? Would you use this symbol, this symbol, this symbol, or the therefore symbol? What would you use? So pause the video and think about it. If x is 5, you would say this implies that x is odd. Okay, and that's just simply a definition. 5 is an odd number. Second one. So if f of x is continuous, so you need to know some calculus here, then what does that say if f of x is differentiable? So pause the video, think about it. It's kind of a tricky one. It's a definition kind of thing too, but it's a little different. You would say that f of x is continuous is implied by f of x is differentiable. Remember that differentiability implies continuity, but continuity does not imply differentiability. The reason is you can have a continuous function that exists as a corner or a cusp, but it's not differentiable there. So that's why it's written like that. Okay, let's do another example. If the graph of f of x never touches the x-axis, and you have this other statement, f of x equals 0 has no real solution. What is that saying? Pause the video, think about it. Well, they're saying the same thing. If it doesn't touch the x-axis, then there's no solution, so it's just saying the same thing. So you would say it's the if and only if condition. 4, f prime of x, or the derivative of x, is equal to 7x to the 6th power. And you also have f of x equals x to the 7th. Pause the video and think about it. Which arrow would you use? Well, you would use A is implied by B. Because the antiderivative, you can have a constant. So you could have f prime of x, if I had x to the 7th power plus 7, the derivative would be still 7x to the 6th. If I added any constant, it would be 7x to the 6th. That's why it's the f prime of x is implied by f of x being x to the 7th power. Okay, number 5. If you have x equals 1 and the second part is x to the 4th equals 1, what does that show? Well, it would be that if x equals 1, this implies that x to the 4th equals 1. You know why? Well, because you could have negative 1. X could be negative 1 too, so keep that in mind. 6, last example. Sine squared x equals 1/4, cosine squared x equals 3/4. Pause the video and think about it. Alright. Oops, gave it away. You would say if and only if. So sine squared x equals 1/4, if and only if cosine squared x equals 3/4. And what that's saying is, because sine squared plus cosine squared equals 1 squared, these two here, 1/4 and 3/4, add up to 1, so the statement is true. So that'll conclude the explanations for some logical quantifiers. Hope this helped with your math, and when you're doing some proofs or explaining things, you can use these symbols to better show yourself and others, I guess, what you actually know and what is implied by what you are trying to write down on your paper, rather than just numbers all over the page. This will really help you have your work written clearly and understood. Hope it helps.